Welcome everyone. In this lecture we try to explain the physical way to measure blood pressure by sphygmomanometer. There is a brief or sketch for explain the physical work of sphygmomanometer. This consists of bulb for squeeze air through both the manometer and cuff around the upper arm, manometers and cuff. To measure pressure by this method, we squeeze the bulb and air will rush inside the tube. It goes to both the manometer and the cuff around the arm, and this pressure transmitted through the fluid, air, to both manometer and the curve around the brachial artery or around the arm, and diminished. Therefore, it will be equal on both sides. So, as inflation of the cuff increase the pressure around the arm and increase the pressure around the arm close the brachial artery. Deflation of the arm reduce the pressure around the brachial artery and let the blood to pass through the brachial artery, and by stethoscope we can hear the motion of blood flow through the brachial artery, and in this way we can read the height of column of mercury. It's about 120 millimeter Hg, which means this is the systolic pressure. When this is the systolic pressure, when the heart is ejected the blood pressure, it will be high pressure. It's about 120 millimeter mercury. When deflation of the cuff continuously deflation of the cuff, the pressure around the arm will decreases until there is no sounds here by the stethoscope. That means this is the diastolic pressure, where diastolic pressure is about 80 millimeter mercury, and in which there is a laminar flow and no turbulent flow, no sounds, and by this way we can measure the diastolic pressure at the rest of the heart. From page 3 from your lectures, you need just the following relationship between the units. You need that 1 millimeter mercury equal 133 Pascal, which units as a unit Newton of meter divided by meter square, which equal 1.36 centimeter H2. This relation by which we can get any other relation we want to calculate. So you must keep in mind that 1 atmosphere equal to 760 millimeter mercury. Here we have example. We want to calculate example. What height of water will produce the same pressure as 120 millimeter mercury? As you know that the height of column of mercury used as to measure pressure at the base. If we have 120 millimeter mercury is the height of column of mercury. So what height of column of water we need, or calculate the height of column of water to exert the same pressure at the base as the pressure exerted by the height of column of mercury of 120 millimeter mercury. For mercury, we calculate the pressure at the base and the law that we use to calculate the physical pressure at the base that the column of mercury will exert on the base. Pressure equal density of mercury, acceleration due to gravity, height of column of mercury. So we know that the density of mercury 13.6 gram per cubic centimeter, acceleration due to gravity it's 980 centimeter per second square, and the height of column of mercury as we get from the question is 120 millimeter, and we use here 12 centimeter to be the same units in the equation, and the pressure we get one pressure of the column of mercury at the base is equal to about 1.6 times 10 to power 3 dynes per centimeters, and you can calculate this if there is a mistake in our work. So for water we want to calculate the same pressure at the base but of water, but we want to get the height. So this is the same pressure, therefore the same law, pressure equal rho GH. So 1.6 is the pressure because we want the same pressure in the water and the mercury, which is equal here the density of water 1.0 gram per cubic centimeter, and the same we act the two tube acts at the same acceleration to gravity. It's 980 centimeter per square times the height of column of look that we want to calculate, and by simple algebra we can get the height of column of water to get the same pressure at the base, which is equal 163 centimeter water. Therefore we see that we use manometer, mercury manometer to calculate high pressure because the height is just 12 centimeters, and cannot use the height of column of water to calculate the heart pressure or systolic or blood pressure, because we need the column of so height, and this is it's impractical to do this. Thank you.